Real life boys. Hey, I have my desktop already muted. It's fine. Um, I need to check how my stream audio is sounding like. So give me a moment. How's my keyboard picking up? These strokes are loud. Am I even audible? Hello? Hello? Okay. So I fucked up the audio settings. Let me see if this makes any difference. Alright. All right. Compressor is turned off. Gain is turned off. And that makes it a lot more bearable sound. Interesting. So, who's in chat? So today's topic is to open the attack time less as whole time. About the open threshold. Right? About the high. If I speak really loud. Yep. Okay. I don't need extra gain or compressor, but I'm gonna try the gain. Let's see how that goes. Yes, I am on 12 dB gain. That sounds awful. Change back to 5 dB gain. Still not good. I'm gonna move gain. and the compressor, does that help? Does it help? So the compressor ratio is like 10. Code noise is something to take care of. What if I right? Alright, how about this? I think this is fine. Checking audio 1, 2, 3. Check, pop. Cool. Um, so purpose of compressor is to maintain the highs and lows. Sorry if somebody is watching and not finding the content they're looking for. So I'm setting the stream up, and I'm sorry. This should be only the case for first couple of days. Once I find out all my right settings, I should not be bothered with all these things anymore. So for the compressor, I'm working with now 10 ratio of 10. So what if I speak really softly? As in, I don't want to shout to make a speaking voice. That is way too low on my. Um, I would need a better microphone for this. But my regular voice, this should be totally fine. And if I'm really loud, I'm not going to go louder than this in ideal cases. So I turn the compressor off. Okay. Does that help? So I have put the output gain for the compressor to 5 plus 5 dB. This is sounding better. Alright, so this just didn't catch. I cannot be this low. Also the directionality of this. Alright, how about that? This seems a lot cleaner audio. I changed the attack. Forget about it. I'm gonna pay $100. I'm gonna leave the audio at this for the time being because it seems like there are decent output level. I don't know how this up way too much. Okay, so I tested the compressor to bring it into the higher. I feel very comfortable speaking in this voice. This is the sound that should be. The noise gate is making shit difficult. But so what if I reduce the close threshold minus 40? In that case, it should not randomly just close my mic audio between my close-ups. Sounds good. This is okay. Let's go. Yikes. Yikes. Hello. Hello. So I tried changing scenes. It doesn't work. Boy, bad. Anybody there on the stream? Say hi on chat. I'm not monitoring my YouTube chat. Sorry, yeah, YouTube chat. Let me find out if somebody's watching there. Might be mages. I don't know. Good idea. That is what we. Oh shit. Um. I think I should change my game to. Sure. Mhm. So, by the way, if somebody's watching and they don't know, like they just joined later, I was supposed to discuss about IoT devices and stuff, but the person who asked yes the last stream, they're not here. So basically, nobody was watching. So I thought that it would be kind of pointless to talk about it because I thought it would be an interactive session. So I thought I would just play games, and next day, whenever they arrive, I'll continue the discussion. Um, but if you're here and you wanna listen, that totally down. Let me know. If you're on Facebook and you know me, then please let me know that you have watched, you were watching this stream. So that at least somehow I know who's watching the stream. And if you're a stranger, hello and welcome to the stream. I'm a new streamer. I'm not a professional streamer, just amateur streamer. I enjoy streaming. No need for donation or anything. I just like to stream. I'm not trying to make money out of it. Um, so I would be a bit less interactive unless there's something on the chat because I don't really know what to talk about. Um, as I said, some I posted on Facebook today morning that I wanted to talk about topics effectively about IoT, edge computing, because last week I was streaming on about assembling a Raspberry Pi, and I was asked to cover that topic. I thought that I'll start talking about what are the devices that you can use, what are the boards that you can use for IoT, which one is actually useful for whichever purposes, and then not only that, uh, the boards are basically mini computers, but what makes IoT devices pop doesn't stand out apart from general purpose normal small computers are the sensors and the connectedness essentially. So that brings it to the point that what are the things that you are building on top of? What are the things that you're um, using to make it an Internet of Things solution? And for that matter, the topic comes down to the sensors that you're using. What are the sensors that you're using and how you're using them? How do they connect? So the interfacing part of things, how the GPIO pins work, and then there are some standardized interfaces as well, some semi-standardized interfaces as well. For example, take the example of camera, right? The imaging sensor is something that is very prominent. Like that's pretty much probably, like, if I'm not mistaken, that's the most by a large margin. That's the most used sensor in an IoT device, camera module. And the interface for camera module generally, uh, so there are two kinds. Most prominent one is MIDI CSI port, camera serial interface. MIPI is a standardization body that makes those standards. So it's like a ribbon cable. I actually, so in my what I was planning that I will go through uh, as I am speaking. I'll Google through the topics and show you the images and stuff of how they look like. So for the time being, you have to excuse me from that because I'm playing a game. But if you know about ribbon cables, like they're like yellow tapes and they have connectors on the ends of them, at the ends of them. So, but damn it, just focus on this guy. He has no HP. Anyways, stupid Luno. Um, so and that ribbon cable can have a number of connectors. So generally, there are 22 connectors in a APCSI interface, but you can choose to use less number of connectors than that because some of the connectors are strictly um, same position. So some of the there are four data channels if I'm not mistaken, and you can choose all four data channels or three of them or two of them or one of them, and depending on how many number of data channels that you're using you can have a standard definition video, high definition video, 4K or 8K video, right? The bandwidth actually goes crazy when you use all the data channels. It's actually faster than USB 3 even. So it's not really possible to one is to one convert um, that APCSI cable into USB interface. There's another challenge that the raw image data, so it doesn't really work the same way. So USB is not basically compatible for CSI interface out of the box. because the data that you're getting from camera interface is a raw image data, image sensor data, basically that contains the values of red, green, blue, etc. This is not in any sense image. This is just electrical highs and lows. That's it. Uh, then you need a chip. So if you see on Raspberry Pi or some other camera module boards, there's a small chip that does the translating part of things, like translates the um, those highs and lows into image data. So how we consider images um, as computer processable data. That's how it turns into. And after that happens, then only we can. Not sure which one I'm going with this. So after that happens, then only you can use it to view on computer screen or something like that, because otherwise you cannot see that image. Now, so now once you have gathered the data, you translated it, and then using it to view or output it, usually that chip is something that is a hardware chip, but you can also do the same thing with software. That's where the drivers come into the picture. So you can take that raw image data as data channels and then say that, okay, do this transformation on this data channel, and then whatever the result is, give me that result. And if you do it carefully enough, you get usable. Hey Shumit, hello. You get usable. I lost my thought process. Sorry. Yeah, so you get usable image just the same way you were getting from the hardware encoding of the sensor data. So you can do it both the hardware and software way. Generally, when you're using it with a Raspberry Pi, the Raspberry Pi has the driver to convert, like, the encode the sensor data into images. So that's what is happening. And so the device that you're using is called sensor module in that case. But if the sensor comes with its own hardware chip that does the encoding and then sends the image data, then it would be called a camera module. That's when it's a camera module, not sensor. Redwood, give me a look. Yeah, thank you. निकाल के घूमिए बोल से. All right, let's fucking go. Yes. Yep. Yeah, the chance. Where was I? Okay, I was talking about the sensor module versus camera module. So that kind of difference can be there for other sensors as well. If the device sends raw data, then it's a sensor. But if it processes the data and outputs something that is recognizable by the computer, then it's a module that is the device module, and it's not a sensor module anymore. So that's the difference. That's the general difference. I was also talking about maybe. This stream is not sponsored by Red Bull. I just like Red Bull. I'm having it for after like 6 months. You have to excuse me. Not go with a lot of antlers and hunters trolling. So maybe not only does camera specification, standardization, camera interface. They also do um, display. So even Raspberry Pi, I'm bringing up Raspberry Pi way too often just because kind of has been the most used or most commonly accessible device, board for IoT and tinkering. So makes sense. It's most common. If I keep on naming the random or like less common ones, it will be hard for to follow. So stay with me. And what I'm meaning is just standard. It's not anything specific to Raspberry Pi in any sense. But Raspberry Pi has this. There are two distinct MIDI ports. One is for camera, as I talked about. Second one is display interface and the DSI. What this DSI does is that it takes raw image data and sends it out. So you basically can convert that into image data that basically is scanning data that you can then show it on HDMI screen. So you can create HDMI or DisplayPort adapter out of a DSI, and you would need some sort of encoding, decoding in order to make that happen. But yeah, it should be fairly possible. That's how the display and camera interfaces work, mostly in the IoT space. They have a specification where it has a ribbon cable to read it, has a ribbon cable and about 20 to 22 wires, connectors in each one of them. So with that said, let's move on to whole fine gateway. Okay. Yes. You know what? Let's look into it. Okay. So that is one of the interfaces I was talking about. One of the interfaces, one of the kind of interfaces that is standardized to some level, to some extent. Most of the smartphones that you're using, those interfaces are really proprietary. They are not really standardized. I tried opening a lot of smartphones, etc., in order to see if that we can reuse the camera module or other modules from there. Doesn't really seem to be that way. They really don't care about EUS or anything, or the reusability or upcycling or recycling of the parts. They only care about making devices as cheap as possible and intentionally so that the parts cannot be reused. Anyways, yo, Gautam, dude, I started playing Dota Underlord because you were not there. You Underlord, dude. It was not playing Underlord. There was nobody watching, so I was like, "Fuck this shit! I'm gonna go play some Underlord because nobody's watching." But now that you guys are here, my babbling would make more sense. I was trying basically, I don't know who else was watching, so I was keeping on babbling about the IoT devices and the standard specs, starting to at least talk about those. I don't know since when you have been listening, so I didn't really cover the boards. I just started talking about the sensor modules and their ports. I just covered the MIPI CSI. Check out the VOD. I'm not gonna repeat that again. So the camera modules. Why am I losing so hard? Who is this guy? This shit. It broke my spirit. So what I was talking about is that some of the things, some of the connectors are not standardized, some of them are standardized, and thankfully, most of the display and camera options are standardized by MIPI standards. The camera ones are called CSI, and the display ones came 5 minutes ago. I got that. I was working on a computer equipment in general. I understand, man. No worries. So yeah, so I was talking about those things. Did you hear about the CSI 22 lane ribbon cable part? I'm not gonna what do you call it, repeat that part, but just saying that I covered that. So that's one thing. I actually intended to cover that in like, opening the browser and showing the stuff, and I will do that. But for the timing until this game ends, let's continue talking about it. Or if you prefer it this way, as in instead of me showing it, whenever I'm saying some things, you can just continue like looking those things up in your browser, and I can continue playing the game. Because I think that can be a pretty good format for the stream. Like talk about a topic while playing the game. Because I'm not really tryharding the game or anything, so it doesn't really make sense for me to explain the game. But it's something that is running on the background. I think that can be something. Cool. Hashtag lazy. What the hell? Not lazy. It's just it would be boring to show like in for me to Google up stuff and also using the keyboard. It will hurt your ears. How does it feel? See, it's not good. Anyways, oh, you were hashtag lazy. That's what you mean. Anyways. Okay. All right. Um, let's talk about the boards then. The most common boards and the uncommon boards and some specific boards. Which ones you should be using for which purposes, right? So there are, so hands down, there are two particular sets of boards that are really common and popular, right? One is Raspberry Pi. One of them is Raspberry Pi, really popular. I will come to the details of it, but you guys know. Second one is Arduino. You probably heard about it, probably have seen it or anything, but the Arduino is less of a general purpose computer, more of a just tinkering device. It does not really have a common general purpose use case. Like general purpose use cases, you cannot really open a YouTube video on that thing. That wouldn't make sense. But with Raspberry Pi, it can run on a Linux. It's an ARM architecture device, and then you can open video, like you can playback video or do anything else that you can or want to do in a standard regular Linux operating system, barring the fact that it's kind of limited in resource. So that's the only limitation. It's not very strong. Get unidirectional mic. So my mic is kind of unidirectional. So I was setting up the audio at the start of the stream. This is the best I can get for the time being. I know this is not ideal. I will get better at it. I am ordering some of the stuff that will make the stream better, but you have to wait for that a little while, as in another week maybe. So to get back to the point, what I was talking about was the device as in the boards. Arduino is a system on a chip. The chip is really not a general purpose chip, not an ARM chip. It's a very specific microcontroller that allows you to control the general purpose IOs, input output ports of the board. That's pretty much it. It doesn't have any other purpose or utility of running a general operating system. It has its own instruction sets and stuff, which is very simple one, but it doesn't have any general purpose use case. Whereas Raspberry Pi, it's an ARM chip, ARM board, and has a very distinctive use case specifically to run computing tasks and to allow kids and people who want to get into the tinkering industry, allow them to get into this world without having to know a lot about the ecosystem. Like, you don't need to know a whole lot. Just get started with a Raspberry Pi because it's the computer you already know and love and you have worked on. The convergence of the devices that you already have worked with, like a desktop PC or a laptop or a smartphone, they have a familiarity in them. Like, you can open applications, you can play with them, anything that you need to connect. There is a control panels or of some sort where you can go and add or remove things. Really not focusing on the game, but somehow it's turning out okay. I don't know how. Anyways, I just need a Medusa and pretty much sit here, it seems like. Keep on forgetting what I was talking about. So for people to have the familiarity with the systems they have worked with, right? And that's where the Raspberry Pi is beneficial. It doesn't have a high learning curve. You can start anywhere, in anytime you want to, because it is very familiar concept. It is just a computer but smaller. Now, these two are kind of two extreme ends. One is trying really hard to be a general purpose computing device, and the other one is trying really hard to be a tinkering device. But there is a middle ground, right? There is a middle ground, and that middle ground is where most important, most practical, because at no point in time the edge or extreme cases are the most useful ones in practical sense. So there are lots of middle grounds. Some are more focused towards surveillance, some are more focused towards AI, and those kind of devices are the ones you should know about, at least depending on whether you're going to work with them or not. You should know more or less about them, but overall you should know how they work and who's behind them. So in order to talk about those specific devices, the reason I put edge computing as as something that I mentioned in the topic. Holy fuck! I'm gonna pick it up because fuck that shit. Who gets it? Who gets it? Get shit up, boy. Or this. Luna is gonna go bonkers. Arduino versus Pi. Yeah, thanks for reminding. I remember that, but I kind of moved on. I can go 10. So the specific devices for specific purposes. Let's talk about those ones. NVIDIA has a specific device for edge computing purpose. Oh my god, I might just lose my rapier. I lost my rapier! Fuck! NVIDIA has something called Jetson. The Jetson. Jetson. So there are multiple models. you can go with Jetson Nano. That's the I need a the Jetson is for AI related edge computing, and you can use it for IoT as well, the traditional sense of IoT. The reason I say it that way is because it can be used as a FPGA, field programmable gate array. What it does, let me try and give you an example. Right? Sometimes you need a solution, you need a device that can work offline. You do not need to, or you shouldn't need to connect to internet in order to make it work. This is the way. Just like Dota, and it gets you right. I think I should have done that. That would have been much better. I needed a point target than that's the maybe salary help. No, this guy has way too many level 3 units. So when you need offline access of stuff like AI access but offline, you don't want to need to connect online to make the AI solution work. What do you do? And what if the learning capability is also bound to that offline situation? Let's say you want to train camera in the wilderness that takes picture of a bird's nest, like you're researching on an owl or something, and you want to see their patterns. It needs to learn how it does things when it gets out of nest, when it feeds the babies, etc. And you want to train it there and then use it for the next 1 year to make it work. And you cannot rely on the data connection of any sort. You need to make it work there itself. So so in that sense, Jackson Nano would be a pretty good solution for that. What it will allow you to run the AI model, like machine learning models, run the training there itself on the board. Specifically, it has the CUDA cores, etc., to make the learning happen, and then it can use that, perform that operation, like it learns and then also delivers. I don't know what to do about the storm because my HP is too low basically on my heroes. I accepted defeat long time back because I can't really win. Guy has a pretty good lineup. I needed to plan and prepare to play something of a scaled unit, but Sven is not scaled, so it's kind of fucked up anyway. Second place is okay for me. Spreading them wouldn't really help because I need the draw bonus as well. Without the draw bonus, like without sitting stand like as if you notice that draw was at the middle and all the ranged heroes were surrounding her because they all could use that attack speed. I spread them across, they will waste time. It's not that they'll stay there. They'll waste time gathering out, like walking up to draw and standing next to her. So that's where it will get fucked up because I'll waste time walking, and secondly, spreading up doesn't also work because they will group up anywhere. Um, so set from that. Anyways, the thing I was talking about. So Jetson Nano is a board which can help you if you're working on a like a machine learning model and you want to make that machine learning model offline capable and on the edge. On the edge means the compute, the data and the client are close by. They are not too far off apart. Think about it from the perspective of a CDN or something. So if all the data servers were in US, we would have terrible ping to play Dota. That's why what do we have? We have Singapore server, we have Mumbai server on all the regional local servers, so that our connection from clients, that is us, to the nearest node, that's the edge, client to node, server, that edge is like small. That's the intention, is you want to make it small. Smaller that is, better communication, more efficient communication can happen. So and in edge devices, so that's the basic concept, but when you call it edge device, that specifically kind of means that you made that particular distinction way too much, like way too many steps into it. It's not a, you are a client here and the server is in Singapore. When you say edge device, we specifically kind of mean that I'm in here, but the thing that generates data or communicates with the data or processes the data, that is very close by, maybe in the ground floor, or maybe on the other like room's attic, something like that, or the other device in my house, right? Why did I pick Kaya? No. Yes. Um, so in that sense, when we talk about edge computing devices, that means that those computing units, things that will process your data, clients that is giving the data or generating data and getting the result back, but something needs to process the data, that unit is very close by, next to or near to the client. That is the motivation now, like decentralizing, so that you don't need high supercomputers in a data centers, two or three of them across the world. Instead, you break it up into smaller pieces and spread it across everywhere, right? So that's how people are trying to figure out the solutions. And for that kind of solution to work, you need edge devices. Now, all the IoT devices that I talked about, they can be used as edge devices, edge computing devices, for various purposes. Though not all of them will be suitable for all the purposes. That's something to keep in mind. Okay, so there are also a lot of smaller boards, smaller boards as in less popular ones, but they have very distinctive purposes. I'm gonna give you some search queries which would help you find out the ones you might be looking for and you don't know how to go after them, like what to find, what to look for. In that case, look for IoT SoC boards. So too much data, more small bits and data set. Yeah, basically that's what is happening. Eventually we need more small bits of data sets. Because think about it from the perspective of managing data centers. You are creating one points of failures. Each data center is a point of failure, right? If there is a server in Singapore and a really bad tsunami happens, hopefully it doesn't happen, but let's say really bad tsunami happens, shit goes down, and also we need to remember that we are way too much data reliant than we were back in 2004. 2004, Not only that people were not as distributed and connected, because most of the universities, etc., they used data. They had their own servers. Most self-respecting bigger institutions, they have not only university, defense, it can be research centers, it can be anything. They had their own data centers. They had to have that. The concept of having shared data centers were not prevalent. That was right. And people were not connected. 2004 means none of you or our parents most likely did not have mobile phone. 0.1% people in the world, entire world, had mobile phones. Think about it. You knew somebody who had a phone. That's most likely the case. So at that point in time, if a disaster like that happens, impact is much lower. Right? You can have entire data centers backup in a hard disk and tuck it away somewhere else. That would be fine. You have a backup. Now the amount of data that we generate per day would be more than the amount of data we generated an entire year back in 2004. So creating a single point of failure is very risky. Also, it actually creates a lot more overhead. Same data that you just need to run, let's say let's talk about Instagram, right? You're using Instagram app, and what if instead of the Instagram app is applying the image filter on the image that you have just taken? Whenever you wanted to edit the image, it sends the image back to the Instagram server. You apply all the filters and it comes back with the response. It responds back with the altered image. Then you like it or don't, and then change it and go forward. Like, I had Nokia that wouldn't break. We have Nokia that wouldn't break. Like, it still lives on. Anyways, point was, if that was the case, that's how Instagram worked. Instead of working or like editing the image in device, think about how much bandwidth and HTTP calls you'd be wasting for no apparent reason. Your device is perfectly capable of doing that, right? Your device can totally compute that transformation. So basically, you're doing a matrix transpolation. So it wouldn't be efficient to do a thorough loop from the server, the Instagram server. So using that as an example, we can figure, if you consider that the phone that you're holding is the edge computing device and the camera of that phone is the client, or you are the client and your edge computing device, the server is your phone. Now you got the result you wanted immediately on your hand without needing back and forth communication with the server. That is more beneficial. If we can delegate more and more tasks that way, that would be much more efficient. Previously, also the voice calls, right? The conference calls. Most of the conference calls back in, like, even 5 years back, were not based on WebRTC. So what WebRTC gave us is that we'll go raw damage or some more armor reduction. I think it's worth getting armor reduction because we have a vigilant alliance. So one of them starts hitting that one entity, all of them gets benefit from that armor reduction. Anyways, to move back to the point of conferencing used not to, like, they didn't use WebRTC. WebRTC wasn't even a thing back then. It's just starting out. What is WebRTC? So WebRTC does the exact same thing. It creates each of the nodes makes them the edge. Instead of needing to have a centralized server for communication, one-to-one to many communication, like let's say what you are doing with the Discord has a server. It needs to have a close by server, otherwise you will have latency, high speed. You don't hear immediately, you start talking, and then after 100 ms you get to hear me and it stops you. That would not be nice, that would be bad, even though you probably live very close by to me, right? What if we are on the same ISP even? Then we'll be practically on the same VPN. Not private network, it can be considered as a VPN. It's basically an internet. So we have a direct throughput connection, but still it's making a thorough loop back from Singapore. Doesn't make sense. Why should it be that way? What WebRTC does, it puts all the participants in a peer-to-peer node. So each one is talking to each one directly. It doesn't go through another stuff. And that changed communication. Now, most of the communication platforms that we see, like that can be Skype or Zoom or Teams. So most of them, almost all of them have moved to WebRTC because that makes it a lot more easier, a lot more manageable. They don't have to spend money managing server and handling that massive load to keep their customers. The customers themselves do it on their own, and it's also not customers are using more data or more bandwidth or anything, right? Because the amount of data that they needed to send is exactly the same thing. It's just the destination has differed because of the like smarter use case, the smarter way of using it. So these are pretty big actually. As the day goes by, there will be more and more cases of edge computing, because this makes way more sense and the efficiency is actually a lot higher. I don't know why am I not uploading new surveillance. So if you are not familiar with edge computing, I think it's worth learning about it. It won't have server level security. No, so go to webrtc.org to learn about the server, the security model, and how do they implement that. Because what you're saying is a good valid concern, because what you're trying to say is a legit concern that people who were building a solution had, and they have worked around it. I know the specification pretty close to my heart, so I know for a fact that it has better security than server, like the what do you call it, the centralized server. Because if you want to, do you know how end-to-end encryption works? PogChamp for what? I don't know. Anyways, so basically, if you want to, you can use end-to-end encryption on the streams that you are sending, because the browser can encrypt while before sending the data. And that is why, by the way, that is why WebRTC, for WebRTC to work for both browsers, Chrome and Firefox, even others, but they are basically based on Chrome anyway, almost all of them, doesn't matter. So for them, it needs HTTPS source or localhost. So basically it allows you to, it's only encryption, so it allows you to what? So if you're developing locally, then localhost is supported on HTTP. But the moment you're using any other host or origin that is not HTTP, it won't work without HTTPS. So it ensures that all the data that is sent I am looking at my YouTube chat. There has not been any chat on YouTube. And good that you created a Twitch account. Who is blaming you? Good for you. AES 256. Yeah, that's just one. I don't know. I have my YouTube chat open and there's nothing posting there. I will need to create an interface for both the chats at the same time. Where was I? Yeah, so security comes bundled in WebRTC. You can't not have security. You have to have security. So any data that goes out from before it gets out of my browser, before it gets even to the lower level of OSI model, the networking layers, it already is encrypted even before leaving the system. And it's only decryptable on the other end after we have already made a handshake. And that handshake happens when you establish the connection. So only the people who have made the handshake of entering that, participating in that WebRTC call, those are the people who will be able to decrypt that. If you have not made a legit, you post my YouTube link in TG. No, I haven't. You can just go to my YouTube channel and from there you should be able to join. If you are watching my old stream, I cannot help. See if I have that YouTube. Yeah. This is the YouTube link. So does that clarify, Gautam, about the concern about the security? So you can't not have an insecure connection. You have to have a secure connection while using WebRTC. Right. So back to the point, just to summarize, yeah, as the day goes by, there will be more and more and more number of edge computing, basically to delegate all the computation to as close to the user that would be requiring that data to work with, because that is more efficient, and also because previously people did not have as much compute power, and the entire balance, people had nothing and the data centers had some, and overall requirement were balanced. So it made sense to do it centrally instead of requiring all the users to get more data or have data centers on their own. But now we have an exceptional and exponential amount of data that needs processing. Each time we are doing something, let's talk about this particular stream that I am streaming, you are watching, right? Boy, if I had to stream raw video output that gets encoded, then decoded back for you to view, you can go with 6 enters. Yes, go. So if that requires, then think about it. It's a 5 Mbps. Yeah, it's a 5 Mbps data stream, and that needs to be processed exponentially. Is an understatement. Yeah. So this entire video stream needs to be encoded once and decoded 4 times, and that's for me, a streamer that is so amateur that, like, basically I have no view, almost no viewer, only a handful, 4 people, and think about the amount of computational power that will be required, right? So it makes sense to allow the encoding to happen on my side, decoding to happen on your device, and allow the streaming platform to only do the data, what do you call it, data transmission. Now streaming platforms may also provide little more than that. Let's say now, at least for the time being, that if I'm streaming at full HD and you want a lower quality stream because of your data pack or something else, now at least at this point streaming platforms do that conversion, and you can choose to whichever stream you want to use or you want to see. But what if, so basically that what is happening here is I encode the video information, send it out, it gets processed on like one in, multiple out. Like let's say it goes 360p, 480p, 720p, and 1080p out, right? Which is why Twitch does not do that for non-partner streams, but Google does it for everybody. Anywho, so that's what is coming out. So they have a straight 1:4 relationship. That's it. Doesn't matter how many users are viewing it, they only need to convert it 4 times. Done. Not ideal, but that there is a definitive answer to that. But what if in upcoming days we have more computing power on each and every one's devices, and we don't need Google or Twitch to make that conversion? Instead of them converting our this video, it comes on your device and then it gets real-time converted from 1080p to p to whichever format you want to watch at real time, and that will only be possible when you make that assumption that everybody has decent enough computing power at their hand or decent enough data. Because if you're like converting from 1080p to 720, you are not using less data, you're using the exact same amount of data that is required to download 1080p, right? You're not using less data and you're converting that on your device, so your device is overworking. What if the new NVIDIA thingy, the DLSS, like deep learning super sampling, that takes a lower resolution image and then upscales it? So you basically download a 480p image, 480p video, and then upsample it to 1080p, right? In that sense, you are saving the data that you're downloading with little to no loss in quality. But that calculation is happening on your device, on your phone or your computer. How about that? That would give us a significant benefit, significant advantage. And that is something where edge computing would make sense. Because why do you want to download 1080p stream when you can just get the 480p stream and upscale it to whichever format you want to view, right? There would still be a limit, but it's totally possible to do that. Probably better to do that. And it would happen. Like, I'm talking about it right now, but probably next year, using hard. I need to focus here. So whatever company is upscaling, it's not whatever company is upscaling. It's you who is upscaling. You are the one who is upscaling. Your device is upscaling. If you have RTX graphic card, you can do it now. For gaming, not for regular other content, but as I was talking about those things before, now like with the latest driver they released, um, now you have what do you call it, machine learned background remover. So if I had an RTX card, you wouldn't get to see my background. I can just make it so that only I am visible with my chair. That's it. I don't even need a green screen. I wouldn't need to apply so many layers of audio effects in order to make my audio sound somewhat acceptable on stream, because there's a fan going on and you need to suppress that noise and all the other kind of crap. Okay, very good. More going lectures. So that is possible now. That is something that is happening on your system, not in any server, right? And that is the premise of edge computing, that you distribute the entire computing bandwidth that is required for everybody to the closest point from where the data can be used. The transformation, the whatever change you need to make can be used as close to it from the client. And your system is the closest one. You are the client and this is your system. I'm streaming unlisted on YouTube. Only people with the link are allowed to watch. I know. I don't wanna like swamp my YouTube with the streams. It makes no sense. I don't wanna have them listed after my in the video list. Alright, time to make a choice, make a decision. I made my decision. Ow. Let's fucking go. What the fuck? Did I explain the part or did I miss anything? Is there anything else that I need to explain? I need to focus either one. So, okay. Two people affected. Now you're explaining, you explained everything. Okay. You know what? Fuck this shit. I'm getting divine repair again. On Medusa? What? Wait. That's a good idea. Is this a good idea? Monkas. Monka Giga. Let's see how it goes, boys. Otherwise, I'm setting somebody else up for a win. Yeah, fuck that bristleback. Fuck him up. Don't let them come close to me. Fuck him up. Fuck him up. Fuck him up. Fuck him up. Thinking about it, if I did not have the divine repair, I would have lost. Oh, yeah, right. So, did you start watching my game since my last game? End of the last game? I wasn't supposed to come second. I was gonna win that one, but something happened. I started randomly losing. It made no sense. Yeah, she has that kind of effect on me. Whenever she is watching, I'm losing. I'm getting a fuck ton of divine rapiers. I don't know how and why. Hey Zero, what's up, dude? I was talking a lot for a while. Then I took a little bit of break because I was just trying to focus on this game. I was not tryharding, but I just don't want to lose on the bottom four. So have to excuse me for a little bit. When did you join? Welcome to the stream, by the way. Hello. If there are audio issues, if there are other different kind of issues, please let me know. I'm trying to actively fix those problems. You guys should play Fall Guys and stream. Is Fall Guys a room exploration kind of game where it's like that you have to find out who killed whom? Shit, I'm losing my rapier. I'm losing my rapier. I'm actually losing the game. Don't worry about it. I lost. GG. Bye. Okay. Anyways, so is that the kind of game you can stop steal while playing? Can I? I was talking a lot while playing. I just needed to focus a little bit more earlier. Uh, Ultimate knockout. This is a battle royale. From where do I get it? It's on the Steam. Okay, I'll get it. Can we play it tomorrow? I'm down to play it tomorrow. If you guys want to play it, like if you guys want to join, and we can be on a Discord and we can chat. That would be actually much better because right now, think about it. I'm just continuing to speak and speak and speak and speak and speak, and I cannot hear anybody or anything. That is surreal. That's weird to think about it. I think came in and he left. Why you guys don't play party nowadays? Because the pussies they don't play. Do I play another one? Another round? I think no. I'm not gonna play another round right now. Talk a little bit and then close the stream. I've been speaking a lot for 2 hours and voice is already not that good today. It's not feeling good. Waiting for my new laptop. Oh, when are you getting? Which one are you getting? Laptop is not good for playing good. Talk to the 75% player base that plays in laptop. I think more than that. More than that, actually, about 90% player base plays on laptop. Pretty much everybody plays on laptop. Extra players are very rare. I think mostly the internet cafes in Philippines and some people who just want to be on desktop. Those are the only two exceptions. Everybody else plays on laptop. Suggest one, please. Suggest one laptop. I mean, if you have decided already that you want to play on laptop, then I'm guessing that that's not going to be a laptop that you're only going to game, right? You're probably going to have like, other stuff that as well. Something that Raspberry Pi not getting Wi-Fi network. I'll solve it off the stream. Yeah, coding. Okay, so in which case it makes more sense for you to go with. I'll give you a couple of options. Go through. Dell XPS is a pretty good option. Dell XPS go with either newer generation graphics like 630 or 620 integrated graphics, or if you want to get a dedicated graphics, fair enough, go for that. But the system will heat up. System will heat up a lot if you go for dedicated graphics without good cooling solution. It cannot keep the computer the regular way on your bed because it will not vent. That's the main issue that people do, and it will thermal throttle. It will perform at suboptimal rate. Okay, bye, Shumit. So if you're getting a laptop, good ones are XPS. You can go with IdeaPad from Lenovo, and unless you tell me budget, I don't know whether Alienware makes more sense. But Alienware is actually meant for gaming, so they have better cooling, etc. Form factor already accommodates for, okay, yeah, this would need constant and cooling all the time. So about that, so it has better heating thermal solution. So if you want to buy a laptop that is already predetermined to be a gaming laptop, that would be better from the perspective of cooling, because you won't have to worry that much about cooling anymore. And if it's more of a productivity laptop, like let's say the one that I'm using, my laptop is Dell XPS 13, except you do want to get in that case, Alienware is good. There's an Acer board. So do one thing, better than me, go to Linus Tech Tips, and Linus Tech Tips has another button, like as in every YouTube channel has, like, there's a channel thingy, and there are a lot of different channels for Linus Media Groups. There's a short circuit, there's a tech quickie, there's all the other kind of shit. The short circuit does very good, focused on this particular device we're focusing on. So they have a lot of gaming laptop reviews, and as well as main their channel as well. Go there and go through or look through the things that they have reviewed, right? You'll have a general idea, headspace. Okay, so these were the models. Some of them are maybe 2 or 3 years old. Hey Zero, thanks for following, man. What if yeah, that would make more sense here, coming from my brain. You guys wouldn't know right now. Yeah, Dev today is good. Yeah, Dev today. You can there are a lot of options. What I'm saying is that don't worry about the current model. Go and look for multiple different reviewers talking about gaming laptops, right? You will know who are the OEMs are, what the vendors are, what are their models, and what are the things they are good for. Some of them are good for better display, some of them are good for putting in more and more crazy weird shit, some of them are good for aesthetically, as in if everything works like well-rounded setup, some of them are very good for heating solutions. So look through all those things, and now you'll have a better general idea of what you need, that you can, so you will start sorting down the favorites, like, okay, no, this company's laptops is generally this way and I like that, I want to go for that thing. Otherwise, if I give you my opinion, there will be value mismatch. Things that I like, let's say I bought a productivity laptop and not a gaming laptop intentionally, because I don't want to deal with the heating problem, because I know that I'll be gaming on desktop and I don't want to do that on laptop. So my focus was completely on very sleek laptop with a good display, good keyboard, as an aesthetically pleasing laptop with a very good performance, and very like pretty much low power consumption. What's the sweet point? If I go too low power consumption, then the processor will be too bad as well. So that was my sweet point. That's what I went for. I went for XPS 13, the very high density display, pretty good performance, like really good performance. That's what I get. Okay. Playing data and running Azure server. Azure server running as in connecting from as a client, connecting as a client, then you're set. Like that doesn't take much. And if you by running Azure server you mean by by running Azure you mean like running a cluster or something as a Kubernetes cluster, then you need something pretty beefy. You should go for Alienware kind of stuff, like something on the edge like that. And in that case, you will be not getting the full value of your money. I wouldn't suggest going for a laptop in that case. If you want that performance system, you should definitely go for a desktop. But there are really good beefy solutions from Dell Alienware and Lenovo ThinkPad. Those are the two my favorites, like go-to favorites. There are other options, of course, generally, but those are all things considered. They come out ahead in more often than not. So look into ThinkPad. ThinkPad has lots of different families. Don't get confused. The professional, you want the professional one. There's no gaming ThinkPads, but workstations with high-end graphics that would kill most of the other gaming laptops. They're not aesthetically pleasing though. It's like a big black brick, kind of like rectangular shape thing. Nodes and clusters. Yeah, so I think in that case you should go with a Lenovo ThinkPad and not a gaming system. Okay, I'll look into it today and probably give you a couple of names or model numbers tomorrow. You can then go ahead, or maybe just look into it today and then we can talk about it. That's it for today, and I hope you guys are coming tomorrow. I'll be streaming tomorrow as well, exactly same time, 8 to 10, every weekend, right? There will be a topic set. So the reason I'm setting ending with this, not because I want to I don't want to say it every day all the times, but there will be a topic set. I'll be talking about it, and if there need be, I can go through it, opening the browsers, etc. Otherwise, I'll just be playing game in the background. I'm not gonna try hard in the game or anything. Main focus is like getting some points across, talking about a particular topic. That's what I did. Hope whoever was here, you liked it. If you have any feedback, please let me know. My stream chat is actually something that accumulates data, so if you post it when I'm not streaming, I'll still be able to see it. Otherwise, you can send all the details to my Twitter account, which same handle, developer everywhere, or on my Facebook. Thanks for being here. Bye.